in the effort to reduce plastic waste in the restaurant industry, single-use takeout containers specifically, University of Michigan researchers compared the lifetime environmental impacts of single-use and reusable food containers. Their findings support the idea that the number of times a reusable takeout container gets used is a key factor impacting its sustainability performance. Depending on the single-use container being replaced, the study found that the reusable alternatives, which initially use more energy and generate more climate-altering greenhouse gases, can break even with single-use containers after 4 to 13 uses. Reducing the quantity of single-use plastics in the restaurant industry by implementing reusable takeout container systems has the potential to reduce greenhouse gas emissions and save on energy, water, and cost. The study found that reusable containers can outperform single-use in all impact categories. The study, published in the journal Resources Conservation and Recycling, reports that on a global scale, plastic production has accelerated dramatically over the past decades, leading to a sharp increase in plastic waste. In the United States alone, more than 90 times the 1960 amount of plastic municipal solid waste was generated in the year 2018. Single-use packaging contributes millions of tons of plastic waste to that total each year. In addition to the number of times that a reusable container is reused and the material type, example polypropylene, the bioplastic PLA, aluminum, the study also found that customer behavior will be a significant factor in sustainability performance. If 5% of customers make trips by vehicles solely to return used containers, the reusable system has higher life cycle greenhouse gas emissions than the single use. The researchers also looked at the water usage of at-home cleaning of the containers. Excessive washing can tip the balance against the primary energy impacts of reusable containers. According to the study, education will be key in counteracting these potential downsides by encouraging customer best practices. Informational labels on containers, signage in restaurants, employee dialogue with customers, and online information are a few educational tools that the study recommends. Convenience can also play a part. City-scale systems with common containers across multiple restaurants may prove advantageous, as customers can return containers to different locations, decreasing the likelihood of customer travel for the sole purpose of container return. Study authors recommend further research on actual customer behavior, including the effectiveness of incentives that encourage best practices, such as discounts to customers wearing bike helmets or meal discounts if returning a container. It is also possible that container deposits could encourage returns, the study reports, citing the example of plastic bottle recycling rates in states with deposit programs compared to those without them. As a base for their model, the researchers studied the pilot program of returnable takeout containers launched by the non-profit organization Live Zero Waste in Ann Arbor. The program Ann Arbor Reduce, Reuse, Return A2R3 is now in its second pilot phase and was implemented in partnership with the City of Ann Arbor's 820 carbon neutrality plan. The Live Zero Waste website outlines the process. Upon entering a restaurant, customers can scan a QR code to check out a reusable container. After the container is emptied and cleaned at home, the customer returns it to the restaurant. The containers made of FDA-approved polypropylene material are then sanitized in the restaurant's industrial dishwashers prior to reuse. The research concludes that a reusable container system, as part of a circular economy strategy, offers the chance for significant benefits over time if customers can be effectively educated to adopt sustainable behaviors.